So if we know the 45 and the 75, we can actually figure out the other two arcs. Because what should all of the arcs add up to? 360. So when you take 360 minus the 45 plus the 75, right? What do you get? Yes, you get 240. Which means each of those should be what? 120. So I know that this is 120 and this is 120.
I got that.
So let's go through the angles. They want all angles. Measure of angle 1. The measure of angle 1 cuts which arc? QR. So this should be half of my QR, right? So that should be 60. Measure of angle 2. See what that cuts. 2. 2 cuts PS. It should be half of PS. What's half of 45? 22.5. Measure of angle 3. Angle 3 cuts SR, which is 75, right? So 37.5 for that one. Measure of angle 4. 4 cuts PQ. So that should be half of 120. Five cuts PS, right? PS, so we're back to half of 45. 6 cuts QR, so half of 120. There's a lot of these. 7, where is 7? There he is. Okay, 7 cuts that one, so we're back to half of 75. And then 8 cuts QP, so half of 120 again. Right, so I'm going to say that this is 50. AB, they just straight up told me, was 120. CD, they told me, was 130. So how do I calculate AD? Just add them. You get 300. 360 minus 300 is 60. There we go. I have all my arcs.
Wait. Why is it 50?
Through this one, there's just 3 of them. So 1 makes up AD. So that was 60. So 1 should be what?
Yeah, it's way easier.
30. All right. 2 also makes up AD. So 2 should be 30 as well, right? And then 3 makes up BC, right? So B should be what? 3 should be what? 25. And there you go. All right, so tangents. They have this figure of a hammer throw event where the guy, they turn around in circles, then chunk it, right? Circle A represents a circular area containing the spinning thrower. Ray BC represents the path the hammer will take when it's released. BC is tangent to circle A because the line containing BC intersects the circle in exactly 1 point. The point where it intersects is called the point of tangency. So a tangent is a line that intersects a circle in exactly 1 point, and the point where they intersect is called the point of tangency. First theorem here, if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. So the line RT is tangent to the circle O. The line segment OR is perpendicular to the line RT. So if you have a tangent line, the radius that touches that tangent line is perpendicular to it. All right, this information is helpful because then that opens up a world of opportunities when it comes to perpendiculars and right angles. Let's look at example 1. How does this help us? ED is tangent to the circle F at point E. Find X. What type of triangle is DEF? It's a right triangle. So how do I find X? Pythagorean theorem. So X should be 5, right? So we have 4 squared plus 3 squared equals X squared.
What was our last one? Plus 16. And they said A squared plus B squared equals MC squared. And I was so like, what?
Theorem 1010 is just the converse of this. If a line is perpendicular to a radius of a circle at its endpoint on the circle, then the line is tangent to the circle. So there's 2 ways to do this. If you know it's a tangent, you can assume that it's perpendicular. If you know it's perpendicular, you can assume it's a tangent. That's all this theorem is saying. All right. So they want us to determine whether or not MN is tangent to the circle L. All right. And so we have a little bit of information here. We have that L to M is 3, M to N is 4, and O to N is 2. Does this help us?
Wow.
All right. This is a radius. What do we know about all radii of a circle? They're all equal. So if this is 3, how much is this? 3. All right. This is perpendicular. So we have 3 squared plus 4 squared equals the sum of these two, which is 5 squared. We know that is true. If a squared plus b squared equals c squared, it is a right triangle, which means that is perpendicular. So yes, it is a tangent. It's a tangent. Does 4 squared plus 5 squared equal what?
8 squared.
8 squared.
No.
Is that true?
No.
That is not true. You will get, if it will write for me, 4 squared plus 5 squared equals 8 squared. This is not going to work, right? No. So no.
So sad.
41 was 60.
All right.
Geometry.
For the first one, you should have gotten 12. And for the second one, yes. If two segments from the same exterior point are tangent to a circle, then they are congruent. So we start at point A. If AB and AC are both tangent to the circle, then AB is congruent to AC. All right? So we have the point in example 3. We have the point A here. Would they want us to find X? Assume that segments that appear tangent are tangent. So they're letting us assume that if it looks like it's a tangent line, then it is. So we know that A is tangent to this circle Q through AD and AC. What does that tell me about AD and AC? They are congruent, right? So I know this is congruent to this, all right? What about AC and AB? They are also congruent. So by transitive property, what do I know about AD and AB? They are also congruent. So I can say negative 2x plus 37 equals 6x plus 5. All right. Add over, you get 8x equals x equals 4. So circles can be circumscribed inside a polygon. Polygons can be circumscribed inside a circle or about the circle. So it can happen either way. On the left-hand side, the polygons are circumscribed, right? Because the circles are inscribed. These are not circumscribed because the circle does not touch every piece. So the vertices of the polygon do not lie in the circle, but every side of the polygon is tangent to the circle. So in order for the polygon to be considered circumscribed about a circle, every single side of the polygon must be tangent to the circle.
So if it were
Okay?
square, then no would.
Yes, if this were a square, that would work. Correct. All right. So what that actually helps us out here is we have a radius, and that'll tell us it's perpendicular. In some cases, if it were a square, it would tell us actually some lengths because the radius or diameter is going to go all the way across it if it's a square. And so it does help you when you're solving things. You know some perpendiculars, and then you also know some distances. So let's look at this next example here. Triangle ADC is circumscribed about the circle O. Find the perimeter of triangle ADC if EC equals DE plus EF. So let's first talk about the information we have. We know that from D to F is 6, all right? D is tangent to the circle at F and at E. So what do we know about DE? It is also 6, right? Same for A to B and A to F, right? They are tangent at the same point. And so if this is 19, we know that this one is also 19. All right. And then they have told us information, EC. So from E to C, it is going to be DE plus AF. DE plus AF, right? So we know that this part right here is 25. And once again, C is tangent at both E and at B. So what do we know about CB? So then how do I find my perimeter? Add it all up. 25. Too big. 25 plus 25 plus 6 plus 6 plus 19 plus 19. We get that the perimeter of ADC is 100. All right. Any questions on that? All right, check your work.
Find the diameter.
Let's look at this. The radius of the circle is 72, correct?
Yes.
So if I were to draw this radius, what would the length be of that one?
72.
Yeah, it would be 72.
How did I not realize?
So this is 72. Then that would also mean that the diameter
Is 144.
is 144.
And then that by 144 or squared is your
No, we're talking about perimeter.
yes,
Times 4.
144 times
And it's
Yeah.
500. And I got it wrong.
Good job.